So I am trying to show a typical example of how the electrons are revolving in the hydrogen atom. It got a nucleus with the electron revolving around it. Let's talk about the factors affecting the electron affinity. You are able to see once the atomic size decreases and here atomic size increases. So once the atomic size, electron affinity is inversely proportional to the size of the atom. Smaller the size of an atom, greater is the electron affinity. As the size of the atom increases, the effective nuclear charge decreases or the nuclear attraction for adding electron decreases. So the electron affinity is inversely proportional to the size of the atom. So increase in size of the atom, obviously the nuclear charge, what will happen? It will decrease. So consequently, atom will be having a less tendency to attract the additional electrons. So electron affinity is directly proportional to the effective nuclear charge. So electron affinity decreases in going down the group and increases from left to right across the period. On moving down the electron, the group atomic size increases, and going from left to right in a group atomic size decreases. This is on the factors affecting electron affinity. I am going to talk about the shielding or screening effect. So electron affinity is inversely proportional to the shielding effect. Here is the shielding effect. Electronic energy state lying between nucleus and outermost state hinder the nuclear attraction for incoming electrons. Therefore, greater the number of inner lying state, less will be the electron affinity. So you are able to see the nucleons and nucleus are out of range, and here is in contact. This one is in contact. So shield animation is nothing but how you are protected. How you are protected. So this is how a person is protected. This is a typical example of shield animation. So the other factor is electronic configuration. The electronic configuration of element influences their electron affinity to a considerable extent. So electron affinities of inert gases are 0. This is because their electrons have stable ns2 np6 configuration in their valence shell, and there is no possibility for addition of an extra electron. So electronic configuration of group 13 elements: boron, aluminium, gallium, indium and thallium. Here is the electronic configuration and the group number and period number. So this is how the electronic configuration of elements are filled. So it's 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d2. It will go on up to 3d10. It will go. This is an example for titanium, which got almost 22 electrons. So electron affinity of beryllium, magnesium and calcium is practically 0. This is attributed for extra stability of the fully completed s orbital in them. Thus, if an atom has a fully filled or half-filled orbitals, its electron affinity will be 0.